Hello, welcome to the tutorial for cold working lab. Now for the cold working lab, your group should have a specification for what % cold work you want to achieve with a given specimen. And so for our demonstration today, we're going to have this piece of low carbon steel that we're going to use for cold working. All right? We'll show you how to set it up on this system and then also some of the initial setup that you need to consider. Now for the first step, in order to figure out what you need to do to cold work, what do you need to do as your first step? Well, as we hopefully remember, for cold working, it's going to be that cross-sectional area. All right? And so you're going to have to start out by using your handy-dandy dial calipers and getting measurements for both the width and the height of our test specimen. Okay? And what that's going to do is that's going to give you your initial area measurement. Once you have your initial area measurement, then you can use the % cold work equation that we discussed in class, and in order to determine what should be the final area measurement. This can help provide some important estimates and desired settings as we look towards compressing our specimen to a specific cold work percentage. Now, as a kind of quick note, it's important to note that this is going to be a bit more of an iterative process. And so what you're going to want to do after you learn how to use the machine and do one specimen, make sure that you take additional measurements of it after you do one pass of cold work to see what your new measurements for your cross-sectional area are. So that way you can continue to refine what your new updated area is after you've cold work, and you can do your best to try to get to the ideal cold work percentage. One thing to remember is that once you have reduced the cross-sectional area, it's not going to be possible to increase it again using a cold working system. Alrighty, doing some pre-work, all right, and doing a little bit of mathematics, we want to target a 4% cold work for our specimen. Okay, and our current specimen has an initial width of 0.125 inches and an initial height of 0.125 inches as well. This gives us our initial cross-sectional area, A naught, of 0.015625 square inches. Okay, now our intent is to get a 4% cold work, and so that's going to be how much our system reduces. So we need to take our initial area and reduce it by 4%. And so that gives us our initial area times 0.96. Doing a little bit of mathematics, our cold work area should be 0.015 square inches. Now, we need to figure out how much do we want to take our height down by. Well, we can think of this as kind of a pseudo-iterative process. So if we take our initial area that we want, or if we take our target area, which is the cold work area, divided by our initial width, that should give us our new height where we now have done some cold work. And we can see that we are going to decrease our initial height from 0.125 inches down to our new height of 0.120 inches. Alright, so that says that we want to take our system ideally down by 5/1000ths of an inch as a good approximation to get it close to 4% cold work, at least for our first step. Alright, now that we have a target for the cold work percent, we're ready to load our specimen into our device. Go ahead and make sure you have your safety glasses on if you don't already. We're now ready to set up our cold work system. So we have our specimen, and what it's going to do is it's going to go onto our rails here, and you can see that we have these two aluminum strips. What those are they are some guideposts, so that way we can fit our specimen in between the two. As you can see right now, there's a lot of a gap, and so what we need to do is we need to decrease the width between these two guide rails. Alright, in order to do that, we can take our vice grips, okay, at the edges, and then what we can do is release them and then pull these together, so that way we can we have relatively little slack in our system, so that way our specimen doesn't have wiggle room. We're going to have to do that on both sides. And so something that can help is if you have a spare piece of metal that is approximately the size of the specimen, go ahead and use that on both sides, so that way when you're trying to put the two rails together, they're going to have approximately the same width. I'm going to need 2 hands for this. Alrighty. Now, best way to go about this is to get the guide rail that is closest to the side situated, then get the 2 specimens of approximately the equal width, and then finally get the last piece, and now you have all 3 kind of in a row now. And then with that should give you a rough guidance. Go ahead and get the first side clamped down. Alright. And then now get the other side clamped down as well. Alrighty. Now that we have the guide rails in place, so that were these 2 pieces of aluminum. Alright, that's these 2 pieces of aluminum. We now have relatively little slack for our specimen to go in and out of our system. The next thing we need to get resolved is what is the height of the rollers. We'll go mobile again. Now, you might be wondering, okay, what settings do we have for that? Well, you can see right here is this cylinder, and so for our system, it is quite literally 2 cylinders, one right here and then one underneath of it that you can't see, and our specimen will go between the 2 cylinders to be compressed. Okay? In addition, we do also have some of these we also have some additional guiders, okay, where those will help to prevent our specimen from curving excessively. All right. Now that we're ready to set the height, we're going to press our specimen in, and you want to be able to see and feel some resistance. And so currently, I'm not feeling any resistance, and so what this is saying is that the cylinder is too high. So what we can do, this is a good way to approximate it. We can see that, okay, we need to put our specimen approximately that far in order to make sure that it's coming in contact with our cylinder. So go ahead and slide it in by approximately that amount. And then what we can do is we now can take a look at our directions, and we can see that, okay, if we roll it, if you're looking down from the top, if you rotate it clockwise, that will decrease the height and bring it closer to our specimen. Okay? And so, oh, there we go. It's now gripping it. Okay. And so now what we can do, and this would be easier to do with 2 hands, you can use your specimen and push it in and out, and then slowly lower the rollers until the specimen comes in contact with the rollers. Okay? So I'm going to do this with 2 hands. You can watch from a distance. Alrighty. And now I can see I'm feeling that initial bit of resistance. Now that I've felt that resistance, I'm going to go up slightly till I don't feel that resistance. Okay? And now that's telling me that that is approximately the height of my specimen in terms of the roller. Okay? Now an important other thing to think about is you should be able to, when you play with this, you're able to see that there's a little bit of slack in the system. And so talk to your instructor if you're curious about what this slack means and how to compensate for it. It's a little bit of an advanced topic. Alrighty, with that being said, we can now look at the markers, and we can see that we have a nice little arrow. And then we can see that these markers, we have both the, if we look at the markers, we can see that for the top, we have nice inch thousandths of an inch for each of the divisions. And then for the bottom, that is a 0.125 metric or basically each division is each division, right, each of these steps is equal to 0.125 millimeters. Now we're in America, so we're going to use our imperial units, and so each of these divisions is approximately 1,000th. And so our current system is just at this marker. And so if we take a look at our measurement, we're currently approximately here. And so we can see that we're approximately at that division that's currently shown. And so we want to take our system down by, let's say we want to take it down by 1, 2, 3, 4, 5 thousandths. If we want to decrease our height by 5 thousandths, we can rotate our marker until we get to the 5 thousandths. Okay? And so what we've done now is we have now placed the height of the roller to be 5 thousandths less than the height of our specimen. With that now being completed, we can now push our specimen in. You should be able to see that it will now hit the roller. Okay, that's a good sign. Now, in order to actually cold roll it, you're going to have to turn the crank. And this will be some manual labor. It should require some effort. However, it should not be too difficult. If it is too difficult, you might be trying to take cold work too hard. Okay, now with that being said, you'll also notice that you're going to want to turn, if you're looking at the handle, you'll want to turn it clockwise, so that way the rollers will take your specimen and feed it through this way. Okay? With that in mind, we'll go ahead and get everything ready, and we'll push our specimen in. You might also need to take a secondary specimen to push it to make sure it's going through. Alrighty. That didn't work. Let's try again. Okay, so it might take a little bit of effort to dial in the height setting, okay? And so it's going to take a little bit of practice to figure that out. Once you have it dialed in though, you'll be able to take your specimen, right? Push it in. You'll be able to feel it hit your roller, then be able to turn your roller. And as you're turning the roller, you'll be able to see your sample disappear from one side and then reappear from the other side, okay? If you're able to do that, that means that you have your height setting dialed in. If it didn't take much effort, chances are you didn't actually do much compression. And so I can show you, if you measure your cross-sectional area, especially if you measure the height that you just were compressing, that will have either it should have slightly decreased if you did any cold working. All right? Once you have that setting dialed in though, you can then take your roller and then decrease it using the notches by that many thousandths of an inch approximately. Okay? So for ours, we wanted to take it down by about 5 thousandths of an inch. So we'll go 1, 2, 3, 4, and then 5 black markers in order to take this down by 5 thousandths of an inch. We can then load in our specimen again, and this time we'll go ahead and give it a good turn. This might require a little bit of effort, so don't think everything's easy in engineering. Go ahead and give this a nice turn. I can actually feel a little bit of resistance this time, though it's not too much, as we're only going down by about 5 thousandths. And so now we have our specimen. You can see that it's actually, if you saw it in person, you could see a little bit of curvature, but not much. That's a good sign. You don't want it to be curving too much. If it is, that means that you'll want to straighten it out. And measuring our thickness, we can see that our cross-sectional area hasn't changed. Oh boy, that sucks. So we got to try again. This time we'll take it down by another 1/1000th of an inch. And we'll give it a good turn. This time we can see a bit more bending, and if you get bending, that's a chance that means that some of these guides could be lowered a little bit more, so that way there's not too much slop in your system. So go ahead and make a measurement. And it really hasn't changed much. So chances are we need to get these a bit lower. All right. Let's try rolling it again. Alright, can measure it again. Alrighty. It hasn't taken it out. Oh, okay. Alrighty, and now we're starting to actually take it down a little bit. Alrighty, hopefully I time-lapsed that. Alright, now finally with all of that work, we can now see that we now have our piece, and you can see that it's actually slightly bent. And so if we now do our measurements, we can now see that we finally got our one height down to just about 0.120 inches. However, an important thing to remember is that now if we take a look at now the width of our system, it is no longer at 0.125, but it's now at approximately 0.127. And so it went up by about 2/1000ths. And so while we did that one calculation, you'll have to iterate, okay, and realize that, okay, now that my width has changed, I need to update my height again a little bit to see if I can get it close to 4%. Do a little bit of math, you'll see that you need to take it down a little bit more in order to meet our target specification. Alrighty, finally after all that effort, we can see that our target spec was about our cross-sectional area of 0.015. I can do my measurements and I get 0.129 for one side and then 0.118 for the second side. And so do the math, that's about 0.01522. So that's about a 2% error in the cross-sectional area. And for the purposes of that lab, that would be a good target specification to hit. So that'd be an acceptable margin. And so while we're aiming for that 4%, we don't expect you to be correct to infinite decimals. Okay, so get it close, So that way, and then make sure that you're recording what it actually is versus what your target specification was for the percent cold work. So that way you know what it is when you go to testing. All right, good luck.